Okay, so we're on page 89 of the exam booklet. We're looking at question 10. I'm going to use this to introduce the next topic. So have a look at this scatter plot. Um, One of the things that I will ask you to do is to describe the association, and there were three keywords: strength, direction, and form. We're really concerned about form this time. Do you think that's linear?
Yes. Kind of yes.
There's kind of
No.
it's kind of curved. Like it seems to be getting steeper further along it goes. Okay? So right now we do not have the tools to do anything that is non-linear, that is not a straight line. Chapter 4 is all about giving you those tools. So, um, because so many people are away today, we're going to do this demo next week. Um, so, but I just want to give you a picture, okay? So here, I've put in the exact same data, and I've generated a scatter plot. So, and the orange line is the line that you get when you fit a linear equation to it. So, think back to last lesson. What should we do if we want to decide whether a linear model is a good fit or not? We created another picture to make that decision. Residual plots. Okay, so on the right here, I've created the residual plot for you. Does that look random to you? Okay, so we'll talk about this later. If you talk to a statistician, they will probably say this does not look random, mainly because of that. It looks curved. What? Oh. Um, you sort of got a concentration of negative residuals in the middle and positive residuals on the sides. So this is an indication that if you just do a linear model, maybe it's not going to work so well. So Tom, Harry, this is what we're going to do this chapter. We're going to change one of the variables by applying what's called a transformation. There's only three transformations we need to know. They are the squared transformation, the log transformation, and the reciprocal transformation. And by changing one of these variables, we're going to get a straight line. So in this question, they ask you to apply an x squared transformation. And I want you to notice a couple of things. So you see here, the r squared value is 0.85. What does r squared mean? Okay, and how do you interpret that? Remember that sentence? Yeah? Remember when you write your report on the SAC, you'll need to refer to the coefficient of determination. So what does it actually mean?
The variation.
Variation in what? Explained by what?
The variation in the response variable is explained by the example.
Very good. So here, I don't know if you can see that. Is that better? Yes, thanks. I'm sorry. I'm long-sighted, so I read small writing. R squared is 0.85. So that means 85% of the variation in y is explained by the variation in x using the linear model. So here, I've just plotted x and y. I haven't applied any transformation yet. Okay, now watch what I'm going to do. Today we're going to look at this transformation. So instead of graphing y versus x, I'm going to take every x value and replace it with x squared. So I might even show you what this looks like. So I'll show you x and x squared. Oh, sorry. Okay, so x is 1 to 7, and these numbers should be familiar to you. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So I'm taking every x value and I'm squaring it. No? So this first line is the x values. That should match the first column on your page. It's x squared. Okay? So instead of plotting y versus x, I'm going to plot y versus x squared. Okay? This is the picture that we get. So I'll go back up. So the curvature is not very clear in that picture, is it, right? But if you look at the one on your page, it's quite clear, I think. Now, have a look here. Do you think this is better? It could be. There's not enough points. When you do real statistics, you have many more data points than this. But I want to draw your attention to the r squared value. Before, r squared was 0.85 or 85%. Look at the value of r squared now. What is it? 94%. So it might be, we might think that maybe we might want to use this model because we're explaining more of the variation by applying this transformation. But we still need to decide whether it's an improvement by looking at the residual plots. And again, there's very few points. Before I said there was a curve here. It's not as curved. There's like this 1 point here. But yeah, maybe you might not think that's an improvement, and that's fine. But the main thing I want to draw your attention to is this r squared value. It's going up now. So the big idea of chapter 4 is if I apply a transformation to one variable, I might get a better model. That's the big idea. Okay? All right. So I think what we'll do now is I'll write a few notes for you. And like to be honest, I don't think this chapter is very hard. The main difficulty is you need to know chapter 3 to do chapter 4. If you can't do chapter 3, you'll find chapter 4 very difficult. Yeah, that's fine. All right, so I'm just gonna pick a few questions from the work program and do them with you. All right, so if you want a heading, heading's always good. In exercise 4A, this is called the squared transformation. So in this topic, we will either plot y versus x squared or y versus x. Okay? All right, so I suspect most of you will find this first question quite straightforward, but it was not well done last year on the SEC. So, I can wait for you for 15 seconds. Okay, so I've given you a formula for y. This could be your equation. In a moment, I'll tell you how to get the equation. The purpose of this question is just to build your basic skills with doing calculations. So if x takes on the value 1.25, y is going to take on a particular value as well. How can I find the value of y? What should I do? It's not a trick question, it's actually quite simple. Pardon? Go backwards? Even simpler than that. You're not solving substitution, that's right. I called it the S word a while ago, I think. All right, so I'm just going to substitute x equals 1.25 into this formula. And I believe this is 1.5625. 7 plus 12.27. Can someone just do that calculation for me? 4, 5. I think that's it.
No, I think it was 9.35.
Yeah. Great. Yeah. Okay. All right. You think you can do that? Do you want me to do one more of that? Okay. All right. So there's that. For the next part, we're going to need to cast a calculator. So please go there.
Oh no, Randall.
Well, I'll be quick.
We're doing an important task calculator demonstration.
Okay. Well, yes. 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 Guys, your year 12's in a maths class. You can't turn up without a calculator. Can't see that, can you? Last time we got around this by putting it on an angle. Let's see if that works. I think that's good enough. Okay, we're doing question 2 now from 4A. Yep, so I need to give you the data. Alright, so guys, what I want you to do is create a new document. List and spreadsheet, we're going to enter in some data. So please make sure you are following this section because you will need to do this on the SAC. If you ask me how to do something on the calculator during the SAC, I'll say, sorry, can't help you. List and spreadsheet, and then please enter in the data from question 2. So I'll call X the EV. What 4A, question 2. So 0, 1, 2, 3, 4 in the X direction. Then the y values are 16, 15, 12, 7, and 0. Okay. Alright. Whatever you do, please do not sit during the exam or the SAC and square every value of x manually. We have a better way to do it. So watch this. Equals, whatever name you gave it, I call it EV, and I'm going to say square. And it's going to do the whole column for me. The x column. So you should have a formula here. If you called it something else, use that. So I'll do it again. Equals. So I called it EV, so I need to do EV squared, and then I use the I'll show you this button here to square the carrots next to the x. Or you can just press this button as well. Okay, so EV to the power of 2.
Oh, can we go from where we
No, you need to enter the formula in a new column. So, what did you call your variable? Maybe that's because it's trying to. Because there's probably another column called x. So just give it an actual name. Yeah, like there'll be an x column and a y column, like very far down. So hands up if you've got this third column here. Okay. All right. So please remember, you don't need to generate the transform values manually. You can do it using the spreadsheet. Okay, so I'll just do it one more time. So it's like Excel if you've used it. Use the formula to generate stuff on another column. Okay. No, it just doesn't automatically. Okay. Alright, so here's what I want you to do. I want you to create a scatter plot using not EV, but the square of the explanatory variable as x. So statistics, stat calculations, linear regression A plus BX, as we've done many times. But this time, I'm going to reference the square of x. So make sure you give it a name before you put it in. Alright, hands up if you've got the summary statistics from the linear regression. Not yet?
Alright.
Oh boy, I lost the slides. Okay, so we've just done question 2 from exercise 4a. And here you were given just a few data points. Okay, so when we did this, when we did linear regression with y versus x squared, so please note x squared, not x, what values of a and b did we obtain? -1. Okay, so here's how you're going to write your equation this time. You're not going to write y equals a plus bx. You're going to write y equals a plus b x squared because we applied the squared transformation to the x variable. Okay, so I'll draw an arrow here. Can you see, Michaela? With the power of technology, I can move. All right, so. Okay, so your equation is going to be y equals 16 minus x squared. Is that all right? No? B is -1. You okay, Brian? You're like rocking around doing this. Okay. Hang on. Okay, year 12's listening. Have I lost you?
Yes. The strawberries phonetically getting divided.
Okay. All right, so I don't want to just keep going. Where's the last point where you were okay? Okay, so to go from here to here, I've just replaced A with 16 and B with -1. Yeah. And there's only one of the x squared. Okay? So if I got different values for A and B, I would update my equation. Okay? Can you see now I don't have a linear model anymore because I got that x squared term. All right, some of you will recognize that as a parabola or a quadratic. Well, we don't need to use that terminology in this course. Yeah. To be honest, I think that's pretty much it. That's all we need for this exercise. The rest is just, you're kind of just practicing using the calculator. And then in question 6, you use words, and that's it. So guess what? 4b and 4c are exactly like this, but we just use a different transformation. So I think chapter 4 is okay, as long as you understand chapter 3. That's the ideal situation. C. There's only 3C. Yeah. Okay. All right. So, would you guys like to do some work now? Okay. Well, I think it's better than me droning on. All right. So, for year 12, before I release the hounds, which is you're the hounds. It's going to be either finishing off chapter 3 or starting chapter 4 today. All right. So, thank you. Off you go.